Okay, this video is going to be on the quadratic formula, and this kind of goes along with the factoring that we've been doing, although this is not a form of factoring. When we have a quadratic equation like this one, and let's say we need to solve it, so we're going to make y equals 0. Okay, and we want to figure out what x is, so to find the x-intercepts. Well, normally we would do the steps of factoring. So first step is the greatest common factor. There's no greatest common factor here. Then you go see if this is a special product, which it is not. Then you would try a diamond problem. You couldn't do a simple diamond problem. You can try a complex diamond problem here. And then you get the -2 in the top and -5 on the bottom. Now, when you try to solve this diamond problem, you'll find out that you can solve it. Okay. Now, that doesn't mean that there's no solution for x here. It just means we can't find the solution using factoring. And when that's the case, we can use the quadratic formula to still find the solution for this problem. The quadratic formula is a formula that is x equals -b plus or minus the square root of b squared minus 4ac, and hopefully you guys recognize this portion from a previous video. It's called the discriminant, and all this is going to be divided by 2a. So this is the quadratic formula. That's the formula. You'll have to memorize that one. You'll see that it has the b's in there, the a's and the c's, and those are the exact same a, b, and c's as we used for the discriminant. And when we start solving the quadratic formula, that's exactly where we're going to start. We're going to start with the discriminant. Couple reasons: it simplifies it a little bit if we simplify the discriminant first, and secondly, if the discriminant is negative, we get a negative number under the square root here, then we know that there's going to be no solution. Okay, there's going to be no x-intercepts, and we don't have to do all the other stuff. Okay. So we're going to solve this one here using this quadratic equations, and first we start with the discriminant. So the discriminant is going to be square root of b squared minus 4ac, where b in this case is, the -5. So -5 minus 4 times a and c. A is 2 and c is -1. So the discriminant here is going to be the square root of, oops, I forgot the square here, -5 squared, 25 minus 8, so -8 times the -1, so plus 8. So that's the square root of 33. Now, it's a positive number under the square root, so I know that there's going to be 2 solutions. Now, we solved this discriminant portion here again. So basically, I can say, well, we did the discriminant, so there is really no reason to do that over again. Square root of, and I can fill in there, there's the 33. Okay, that's the part that we just solved, 2a. So now all I have to do here is take the b again, so that is -5 goes in for b, and for a I'm going to write 2. So let's go ahead and do that. So the b is replaced with -5, so you get a negative times -5 over here. The a is replaced with 2. Okay, so now we get, simplify this one, x equals 5, because the negative times -5, that's 5, plus or minus the square root of 33 over 4. Now you want to see if you can simplify this. Now 5 and 4, they don't have common factors. The square root of 33 cannot be simplified any further. So there's really, these are my 2 answers for x. They're kind of like weird numbers, not decimals or integers. So one solution for x is, one x-intercept is at 5 plus the square root of 33 divided by 4. And the second x-intercept is at 5 minus the square root of 33 divided by 4. So now we found the two x-intercepts for this quadratic equations. We can actually kind of like approximate it. So this kind of squiggly equal sign is approximate. So the square root of 33, that's going to be just a little bit than 6. So we get 5 plus a little bit than 6. So let's go ahead and call this, 5.5. It's not very accurate, but so 5 plus 5.5 will be 10.5 divided by 4. So this here now you can see that is about, this is a real number on the number line. You just need to simplify it. To get a more precise estimate, I'd suggest you just use your calculator. Okay, that's it all for quadratic formula.